Pranami Bharali. I'll be the host of this design lecture. So let's first look upon the schedule that we have planned. So first we'll be giving a brief introduction of the 2024 theme of Design Advance. So for that we have Kanchan from Ethos. So she will be giving you the brief of the 2024 theme, and if you have any questions in between, you can post your question in the Q&A, and then I will be giving you the company introduction, a small company introduction of Capricorn. Then for this first design lecture, we have Chinmay sir from Morphosis. So sir will give you an insight of precast construction, and also we have Shoaib, Mohammad Shoaib. So he is a senior beam specialist here in Capricorn. So sir will be giving you an insight of a little introduction of precast construction. And lastly, we will have the Q&A. So in the entire webinar, if you have any doubts and any questions for them, please post in the Q&A, and we'll be taking the Q&A at the last. So let's start with the first brief of it. So for the Design Advance 2024 brief, I'll be calling upon Kanchan. So Kanchan, over to you.
Hi, good afternoon, everyone. I'll just share my screen and we'll explore the brief together. So, as you know, Design Advance is a competition for students of architecture, design, planning, and civil engineering. This year's theme for Design Advance is Architecture of Assembly, Industrialized Construction for High-Rise Buildings. And we are focusing on residential buildings in particular. As the name suggests, architecture of assembly is based on assembly of precast or prefabricated industrialized components in a building and just assembling them on site. Exploring the theme further, it encourages you to revolutionize the construction process of a multi-storied residential building using industrialized construction, and in particular with prefabricated components to navigate challenges like unorganized labor, workmanship issues, site management, and pollution caused by construction. So your task is to design a high-rise residential building or a complex that provides safe and comfortable living spaces while embodying creativity and sustainability. So it's not just about assembling boxes or assembling building parts with each other. It's also about showing how creative you can be with this process, right from the design table to the execution of it. You may have noticed that like high-rise residential buildings have several repeating elements at identical layouts of units to maximize their efficiency. There are staircases, railings, facades, balconies, toilets, etc. that are very similar or identical in nature and stacked on top of each other. But due to the scale of these projects, like high-rise residential buildings, which is ground plus four, like 5 stories or above, due to the scale of these projects and limitations of conventional construction process, these projects end up taking a long time to be completed and to be occupied. So there are two things here. Not only are they taking a long time to be constructed, it's also that the building owner or the project owner, like they are facing issues like in getting the project occupied as soon as possible. So how can we save time, effort, expenses, and resources while designing these buildings? Is there a way? So can we somehow standardize these elements and minimize the time of construction and somehow maybe produce them in a factory and they can be assembled at the site? So that is what industrialized construction does. So in prefabricated construction, only the foundation is laid using conventional methods of construction, and then the superstructure components like walls, floors, doors, and windows, etc., they can be produced in a factory and then later assembled together on the site. So the first step is standardized elements are designed according to requirements. So you'll design them on a software, and then pass them on to the factory. The elements will be produced in a factory in required numbers. The prefabricated elements will then be transported to the more. If you think about what elements of the building you can prefabricate, you can prefabricate the fire stairs or the elevator, the plumbing system, the cooling, ventilation, etc. Then there are complex elements that may face inconsistency if they are made with traditional forms of labor or traditional forms of construction like the facade or the balcony railings, etc. And the components like walls, floor panels, doors and windows, and toilets, kitchenettes, like an entire toilet can be constructed in a factory and then just put together at the site because we need identical finishes and identical furnishings inside the toilets. One of the case studies that you can look up is the 10 degrees building in London, UK. And you can see how interestingly the facade has been made here. And you can see how like that could have been designed, then created in a factory and then assembled at the site. Similarly, there is these the Quarriage apartments in the Netherlands, and you can see how interesting this facade is. So you don't have to limit yourself to just cuboidal boxes or like just one type of uh, imagery or identity of the building. You can experiment and have fun with the facades and the building itself. Now we come to the task. Your task is to design a high-rise residential building or a building complex using industrialized construction with prefabricated building components. So you'll have to understand industrialized construction and prefabrication of building components to create sustainable, inclusive, and accessible spaces. And you'll also explore some suitable materials because not all the traditional construction materials will be suitable for doing prefabricated buildings, right? And you have to push your creative boundaries and like give us the most creative use of prefabricated components. Now, the next part of the task is to demonstrate how a transition from unorganized to organized construction practices will address the issues of quality, workers' protection, and sustainable design. So you'll maximize the use of industrialized elements in your design. You'll standardize the repeating elements like staircases, washrooms, balconies, facades, etc. And it, don't forget to draw inspiration from the uniqueness of the site, the context, its history, and its local cultural heritage, etc. Like that is always welcome and encouraged. Here are the guidelines for choosing your site and making your program. So you have to choose an urban site in a tier 1 or tier 2 city using the following guidelines. Your site area should be between 5 to 12 acres. Minimum if FAR that you have to achieve is 3 and green cover should be at least 15% of the total site. You have to follow the local bylaws or the national building code in absence of local bylaws. And at least 50% of your design, we'll even say like 50 to 60% of your design should be constructed using industrialized construction and prefabricated components. You have to also show in your design sheets these details like which prefabricated components you've chosen and why you have chosen them and how they have impacted the design process and the timeline of the project, etc. Here are some design considerations, how you integrate the industrialized construction process, how deeply you have research process and its application, how sustainable is your design, how well being is promoted by your design, and how creative is your design. Here are the participation details. The registrations will close on October 7th, so please do register before that. And you can submit your entries till October 17, 2024. The competition is open to all undergraduate and postgraduate students of architecture, planning, civil engineering, and design globally. And those who are graduating in 2024 or have graduated in 2024, they are also welcome to participate. Maximum 3 members per team are allowed. And you're allowed to make teams with students from different academic years in your college as well as students from different colleges. There is no registration fee at all for the competition. The postgraduate students can also take part in this competition. The UG, PG students of all the fields that have been mentioned. Team members can also be from different colleges. In absence of local bylaws, you have to follow the National Building Code. You can choose your own site, just make sure that it's located in a tier 1 or tier 2 city and the area is between 5 to 12 acres. You can define your area programs and like distribution of functions and space allotted to each one of them as per your site requirements. That's it for today, and we'll welcome any questions. You may leave them in the Q&A box or in the chat. Thank you. Over to you,
Uh,
Pranami.
Okay, thank you, Kanchan, for taking us through the brief of 2024 Design Advance. So, if you have any questions, you can post in the Q&A section also, and also you can connect us and Ethos as well. You can reach our website, Design Advance website, and see the detail of the brief, right? So next I will be giving you the introduction of Capricorn. So Capricorn is India's leading design and construction management technology solution provider for the AC in the industry. So we are here from since 1987, and we are located in all the major cities of India like Delhi, Bangalore, Mumbai, and Hyderabad. So we have served 20,000 plus in Indian customer. Plus, we have a 250 plus tech savvy team, and also in there 40 plus BIM experts are there. So Capricorn is now a part of global. So we are now part of Arcan's company. So we are not only provided in India, we also go have in Americas, in the EMEA region, and also in the APEC region as well. So I would like to welcome everyone for joining the first design lecture, which is precast construction and alternative approach. So before going to the insight of it, so we will look upon what is precast construction. So for that, I have invited Mohammed Shoaib. So sir is a expert in it, and sir will be giving you an brief introduction of what is precast construction. So sir is a senior BIM specialist here in Capricorn. For he has been working from the last 5 years. So over to you, sir. So
Okay, thank you so much, Pranami. Uh, Thank you for the introduction. Although I'm no expert of precast, although I know BIM and I have been working here as senior BIM specialist, we have invited one expert today, that is Mr. Chinmay Mohanta. He'll be, giving you the expert lecture on that. I'll be showing you the technology side of it. So before inviting Mr. Chinmay, I would like to show you what precast construction is, which ma'am has briefly explained as well. So basically, it comes under an umbrella term called industrialized construction. So any construction which is gone through the industry and then installed on site is known as industrialized construction. So basically, it has uh, prefabricated construction, precast construction, pre-assembly construction, modular construction, mass production. All of these terminologies you might have heard. These all fall under the umbrella of industrialized construction, where you can improve the productivity because obviously elements are constructed in a controlled environment, and then you can install it on site. That way you can also reduce construction time and safety and pollution on the site. So today we are focusing specifically on precast construction, or we also call it prefabricated construction, where elements are pre-made before sending that to site. So rather than creating columns, beams, walls, floors, any building component, any civil component for that matter, before creating it on site, we actually create it in pieces, in multiple panels, in multiple parts, in a factory setup or on a manufacturing site, and then we send it to the site for installation. So it has two parts. One is manufacturing the component, which obviously takes place in a factory or a location which is away from the actual project location, actual building location, I mean. And then we bring all these precast assemblies, which were planned earlier by the designer. In this case, you people are the designer. So architects, mechanical engineers, electrical engineers together, they sit together and they break the components into pieces while developing their design. And then those pieces or those parts are their drawings are sent to the site, and then those drawings are sent to the factories, and it is constructed in multiple parts and sent to the site. That is why it is known as precast construction, because elements are pre-made, precast before sending it to the site. So what are the advantages? First advantage is it reduces the construction time, because while elements are being prepared in the factory, parallelly you can also carry out the site development activities. So these are two activities going in parallel. This is how construction time can be reduced. Further, you can also improve quality, because factory setup is a controlled setup where you can develop the product with a predetermined quality, which is of a good quality. So you can control the temperature, you can also control the machinery, you can also control various aspects of the factory, which Chinmay sir will also show some of the examples from his project. He has worked on many precast projects himself. So he'll show some case studies. I'm just showing the advantages here first. Then you can also control the safety. So in factory setting, obviously health safety and other safeties can also be taken. So those on-site hazard can be controlled in this way. So safety management is quite easy to handle in precast construction. Then obviously it increases the value, because it obviously reduces the time, like already mentioned. In return, it also reduces the cost. So it's a sustainable approach because it cuts down the environmental impact. Now, because construction is not going on site, so it is not affecting the surrounding. It is not affecting the environment. So getting the environment clearance for such projects is also easier than the traditional way of construction, because it basically helps you to reduce the environmental impact of the construction. Because construction is actually not happening on site; it is happening in factories, and you are only assembling the components on site. So these are some of the advantages, and these are some one case study data where they have reduced 66% of time, 65% of money, and 74% of waste has been reduced. So these are some of the project data. Anyways, now since I'm from the BIM side, I work as a BIM specialist here. I also help in delivering BIM projects. So when we work in BIM, we actually create the entire building before sending it to the site. And we also generate GFCs out of the same BIM model. And in this case, the role of getting the panel drawing is very important. So first, what we do, so because of the time constraint, I'm not, I'm not opening the actual software. I'm just showing you some of the pictures here. So this model has been created in Autodesk Revit. So Revit is one of the BIM tools. You can also use any other BIM tool if that is, in your case, it is mandatory. Revit is one of the most used tools, so that is why we have taken example from Revit. So this is just a general model as you create any model. In this case, fenestrations are finalized. In this case, openings of doors and windows are kind of finalized. Once your openings and the position of all the cutouts are finalized, you can break your model into multiple pieces, into multiple panels. So I've taken only example of a wall, although you can also divide your floors, your finishes, your and every element can be divided accordingly. So we are taking one example for now. We have selected all the walls and divided it into multiple pieces. The division can be automated in BIM platform. That is where you get advantages of using BIM, such as Revit software. So in this case, once it is divided, then you will get multiple types of panels. As you may notice on the left side, some panels having some openings. So the panel shape is different from any panel which is used on the right side. So as you may notice, there are different types of panels in this case. So we tag all these panels accordingly. So we'll get, let's say, 2000 panels, and out of 2000 panels, suppose there are 70 types of panels. So all those 70 types are marked separately, and their drawings are automated. So again, since these are too many panels, now BIM softwares will help us to do it very quickly. So these are all outputs taken from Revit actually. So in this case, you may notice one of the panel is selected and its documentation is done. And once this drawing is ready, it's kind of a shop drawing for manufacturers, for factory owners to build it. We send these panel drawings to the manufacturer. They take these drawings for mass production. They produce panels in their construction yard, and once these panels are ready, these are exported to the site. These are transported to the site. And on site, since we have already created a BIM model where each and every panel is tagged according to the location of the panel, they place the panels by using some crane or any other mechanism. So in this case, on the left hand side, you can see the picture how elements are being installed. Later, Chinmay sir will also show you some examples from his project. He has also delivered such projects. He's one of the experts from the industry. So we are lucky to have him today. Anyways, furthermore, similarly, like for any civil element, we can also do it for the MEP elements. So MEP element is such as pipes, ducts, network of cable trays, network of different services. So you lay out all the services in a BIM model. Once it is ready, once the design is approved, once the design is frozen, then you split the services into multiple parts. For example, this particular service has been divided into 4 parts. Part A would contain certain part of certain duct. Part B would have certain part of another duct. Similarly, part C and part D, it is divided into multiple parts and along the entire length of the duct or along the entire length of the pipe, and then at their junctions their connections are carried out. So MEP engineers will sit together and they carry out the connection, they design the connections accordingly so that they can be easily installed on site. So this is one example where couplers are being used to connect these pipes. So this is one section which is divided from the design model for before sending it for fabrication, and these two pieces are connected by different couplers or different connections. Once this drawing is carried out, when everything is planned, then its drawing is also sent to the factories for mass production, and each of these pieces are carried out, are transported on site on large vehicles, and then it is installed by using the machinery, maybe crane or something. So this is from my side. Now I would like Pranami to introduce Mr. Chinmay sir. He will take a lecture on precast construction. He'll show you one case study as well from the live project. Thank you so
Okay.
much. Over to Pranami.
Okay, thank you, sir, for giving us a brief introduction on precast. So now I would like to call upon Architect Chinmay Mohanta. So, sir is the principal architect and the founder of Morphosis Design Studio, which is in Bhubaneswar. So, sir has expertise and extensive use for the precast concrete. So he has a project, one of the famous project, that is the Jindal Global University campus at Sonipat. And sir has also earned a nomination for the prestigious Aga Khan Award for Architecture and the distinguished Franco-German Embassy at Dhaka. Sir is also a visiting faculty at Pilo Modi College of Architecture, which is in Qatar. So, sir will give us the insight of it. So, sir, you are here with us. Thank you for joining us today. So, over to you,
Hello.
sir.
Yeah, hi. Thanks, Pranani and Soev.
Yeah,
Um,
nice to have you, sir.
Thank you.
Yeah,
So yeah, to let you know, Soev was our instructor for BIM and for Revit, Autodesk Revit. And
thank you, sir.
this project I'm going to show you, I did it in Revit, but not entirely. But then the major part of 80% was done on Revit. So let me just share the screen. And just to correct, like I was working with Stephen Pommier, and the nomination for Aga Khan Award was for Stephen Pommier Architects. And I was working with him for quite long, for almost 13 years. And yeah, let me share my screen for the presentation. Is this visible?
Yes, sir, your screen is visible to
Yeah.
us.
So I'm going to take you through the Jindal precast plant, which was not very far away from Jindal University, because they were doing Jindal Global City was the site was close by. So the precast plant was close by the university. So this is the precast factory, and you can see you have lot of activities going on. So this is the technology, battery mold technology for the precast walls, load bearing walls. So this is more efficient. The other one is tilting table, which is kind of, you have to put flat on the surface. This takes battery mold takes less of space, and it's more efficient than the tilting table. So this slide is for the bed for the slabs. The slabs are casted like 100-meter long, 1.2-meter wide, and the besides to the left is the bed for the beams and columns. This is the mold for the staircase. All the staircase which are used in precast buildings are precast only. So this slide is, you can see all the reinforcement which was done outside, and then it was put on the battery mold for the walls, and all the electrical and all the dowels, space for the dowels are over here. This is the storage of the precast walls, and you can very clearly see all the services cutouts, and all the cutouts for the door windows are already in place. So I'm going to take you through one of the student housing at Obigental Global University. So this is the master plan, and when we started in 2008, when SP Design started in 2008, we had the site was 47 acres. Right now, the site must be close to 120 acres, and Delhi Chandigarh Expressway. This is the north side. This is the north side. This is the north side. You can see the north sign, and the Delhi Chandigarh Expressway is on the eastern side. And here, the main access to the site is Narela Sonipat Road, and the site is divided into two parts. Reason being, the Jagdishpur village, which is close by, the main road of the Jagdishpur village, divides the site into two parts. And here, the circular one is this swimming pool along with the sports complex. The big block at the center, there's the academic block, which is completely made of steel. Then the block next to the academic block, that's the small rectangle, which is close to 50-meter by 50-meter. That is the dining block. And up above towards the southeastern side, another block, that is the faculty housing, faculty office block, along with a helipad on the top. And rest of the buildings, whatever you see, except the three which are on the north east side, northeast corner, those are faculty. Rest other housing are rest of the buildings are student housing, except very few blocks which are smaller ones. Those are the service blocks. So this is the one of the photograph from the campus. Left side is the academic block. Right side are the three faculty villas, which is made of that was in phase one, 2008-9. So these are in cast in situ construction, exposed concrete and exposed brick. Left side is academic block is made of completely steel. Then right ahead we have the student housing which are visible. So for academic block, because within 9 months if you want to do a project, steel is the best way to deliver the timeline. So all the trusses, flooring, everything was on made of steel except the core areas which are of concrete. And student housing of phase one, that was of cast in situ, fully concrete, exposed concrete. So this is a view from the south side, and to the right there is a faculty office building. Then there is sports complex. Then there is an academic block and faculty housing. Here you can see the dining block, and rest other buildings are the student housing. And most of this building, like whatever you see except SH1 and the phase 1 student housing, rest other student housing are of precast. This is the view from the northeast, from the Sonipat Narela road. On the forefront is the sports complex. On the left is the faculty housing. Then you have right towards the sports complex is the academic block, and these exposed bricks are the faculty villas, and rest whatever gray you see, those are all the student housing with precast technology construction. So I'll take you through the case study on SH11. So this is the SS11 block. This is a singly loaded corridor block, but you have, because the site are in two parts, so you have a foot overbridge connecting both the sites. So this is leading towards SH11 and the other SH10 and student housings on this side. So SS13 is yet to be constructed. SH10 and 11 are already constructed. So this is the east side view. So if you see, you have a triple height entrance lobby. Then on the left side, you have one housing block. Right side also you have housing block, which is singly loaded corridor. And then above the lobby, you have the play court for the students. And then on top, you have the roof covering so that they can use the play court at any weather conditions. This is the ground floor plan of the student housing. So you have three entries. One on the main entry is on the east side, and then you have another central lobby that you can access from both the sides, either north or south. And then you have another entry on the west side. And the east side is triple height, and the west side is double height. So the services are marked, service areas, the common rooms are marked. So in between both the student block, you have reading room, and then you have a lobby for the and as a lobby for the students. Then when you come to the this is a third floor plan. When you come to the third floor, then above the lobby you have the play court area. And then when we move up above, then you just have the corridors with connecting bridges for the both the blocks. So this is the section what you see. This was the conceptual section we did to understand the project. So if you see the central space, above that you have the play court, and then you can see the roof covering on top. And because of the there's a Kosh Minar close by, so because of this distance from the Kosh Minar, because it's a national monument, so we had to reduce the height. So one block is 7 floors, while the other block is on the west block is 7 floors, while the east side block is 8 floors. And this to make it simpler, we made only two play courts, one above the reading room and another above the lobby. So this is the play court, how it looks. This was the reading room, the conceptual views of that. So this is one of the typical module of the student housing. So the red color is the balcony, while the gray side is the corridor. And you have the arrangement is like a hotel arrangement. You enter, right side you have the wardrobes, left side you have the toilet. Toilet are partitioned, one is for the WC and one is for the shower. And so at any given point of time, more than one person can use the toilet. And then you have three beds with the bedside tables, and every student has a study desk along with some book storage. So this is a site during the excavation and the raft foundation which is going on. So you can note down the date. Here the date is written 24/02/2001. So why I mentioned all the date of the work progress, so that you can get a fair idea about the timeline of the project. So it was started, the raft reinforcement was started on 24th of February 2021. So here you can see these are the dowels which are left for the columns, precast columns to come in place. And this is the foundation for the column. And so after 3 months, 14th May, so you can see almost 2 floors are being completed. The arrangement of the precast modular construction. You can see from walls to staircase to slabs, everything is precast. So we come after 3 weeks, then almost 2 floors are up. So this is before the flooring. So the slabs are precast, the walls are precast, the staircase are precast, and you can see mark here. Uh, there's this rings. Those are needed to lift up the staircase flight. So for every element, precast element, you do, they have some lifting arrangement. Otherwise, it's not possible for them to lift and put it in place at site. So here, after a month, when you see your columns are in place, the precast columns, the precast beams, uh, the railings, the doors. If I see these left side and right side, you have the doors are being visible, the metal doors. Those are also manufactured at industry, and those just had to be fixed at site. Those are metal doors. It can be like there are different vendors for that, Tata or GMP or Jindal. And this, if you notice, there's the junctions of beam and column, you don't have anything in there. And then every beam is supported by the corbel. Otherwise, how do you support a beam? So I'll show you the details later on. And the top portion of the beam is also left uncast. So when the slabs are in place, they cast it at one go, so the entire structure becomes one. So there's another, from the another angle, the beams and the columns. So this is after 2 weeks. This space. These are the connecting bridges. So here, these are also the beams, metal beams, which were connected for the connecting bridges for the 2 blocks. And the slab which we are seeing, that is the air handling unit, AHU room, for the reading room or for the lobby space. And you can see the cutouts. These cutouts are pre-planned uh, before it comes to the site. These are for the HU ducts. So here, if you see, because the timeline is very strict in terms of the coming of the joining of the students to the campus, so it can't go beyond, because the students need some accommodation. It's a fully residential campus, so the deadlines are very strict for the uh, finishing of the projects. So here, if you see, these are, you can see like the walls are up, and some portions which you can see the reinforcement, minimal reinforcement, those are not casted yet. But at some portion, you can see uh, those are already casted. The slab are kept, and all the structural topping is already being done, so that they can lay the floor. And whatever you see at the central portion, those are the hollow core slab, because there might be there are solid slabs, there are hollow core slabs as well. The solid slabs can be 100 to 120 150 thick, while the hollow core, those are for the shorter span, because room to room we have solid slabs which the span is 3.75, whereas when we go for the columns and beams, the span is 7.5 meter. So in that case, we had to go for hollow core slab, which can span for 7.5 meters, and those are 200 thick. and we can't. Then the columns are placed at 7.5 meter grid, and because these are load bearing walls, and column beam are the frame structure, so we need to have a expansion joint in between. So this building, the building total is close to 100 meter by 36 meter, 35 meter. So we have at least, like, in one of the direction of 100 meter, we have expansion joint, and then we have expansion joint for the precast columns and the load bearing walls, and then we have expansion joint in the bridges. Bridges we can't give in the metal, so we had to give it, the expansion joint was in the slabs, the hollow core slabs. So this is after 1 month. We are almost up to seventh floor, which is almost the top of this block, and then the other block is one level up. So in the same time, we had the terrace soft work also going on, and the precast slab would come and be in this place as a soft covering. And then here all the cutouts, whatever you see, those are for the services, the exhaust of the toilet, the rainwater pipe, the evacuation of rainwater pipe, and the walls which are taller, those are to take on the roof covering, which is in metal. So this is the play court area, and this is under construction, how it looks, how it was looking. And you can see the connecting bridges right ahead, and the slabs are already in place for the corridor. This is the reading room where all these column, beam, and slabs are in place, and the flooring is also done. Uh, this is the structure for the roof covering. Entire thing is made of steel, and the ducts, exhaust ducts, and are in place. And the flooring for terrace tiling is already done, along with the waterproofing. So here there will be roof covering, and top of that there will be solar panels. This is the air conditioning is in place. All the electricity on this area is in place. So this is a triple height lobby space, and the doors which are being visible, those are for the entry to the rooms. And this is one of the typical room where you have 3 beds and 3 study tables along with a toilet. So this is all fully air conditioned, centralized air conditioned. And the toilet walls, they are also ecotech. They are not made of bricks or anything. So ecotech walls are also 600 width, and they are produced in factory, the same technology, Alimatic, and they are just bought in place over here, and they are placed over here. Those are non-structural walls, and it goes way faster. Like probably the workers, they could do 3 toilets in one day, complete 3 toilets wall portion in one day. These are some of the images from the bridges towards the play court and the roof covering. So this is the west facade from the another student housing assistant. To the left, it's a to the left there is another building which is of cast in situ conventional structure. Then to the extreme left, that's also a precast building. So by 18th of November, the building was complete. So we started somewhere in January. Within 10 months, the building was complete in all respects. Here you can see all the water heaters, exhausts for the toilet, the 5 water tanks. These are the finished images. The staircase area, the connecting corridors, the lift you can see. At the center, you have a skylight. So this is the image from 7th floor. So this is a complete finished building, and everything was done, like even extra landscape and all that was all completed. So this is from top floor towards one of the other student housing assistant, which is behind, and they do have a play court also on top of their terrace. And that's also, you have precast column beams. That's also a precast building. So this is one of the typical layout of precast structural drawing. So here you can, at the center portion, you can see all the columns, and rest others, whatever you see, those are the precast walls. So this is a blow up version of the same. These two are the lifts, these are the precast columns, these are the shafts, and these are the rooms. And every room has a nomenclature. Very important thing is, we can't produce, because precast needs a lot of storage space. So we can't produce similar walls at one go. So we have to finish the one ground floor first, then we have to move floor wise. Otherwise, what happens? You need a lot of storage space for the walls. So this is a slab layout, typical slab layout. So I have a blow up plan to make it more clear. So here, if you see, the central slabs are hollow core slabs, which are spanning for 7.5 meter. But the rooms, within the rooms, those are 3.75 meters span. So those are solid slabs, and in central space, you have hollow core slab. So these are some typical junction details. The foundation was done in cast in situ, and the dowels were being left. And then precast columns come in place, or precast element wall would come in place. So most of these grade of concretes are really high. So for everything is M40 except the column and the slabs. Those are M50. And in generally, in columns, what you have is, in typical cast in situ columns, you have very less of reinforcement, probably 8 to 10. But here you'll find like 30 dowels or reinforcement which are left for the column, for the support of the columns. These are typical wall detail, how the wall is being fixed. So the dowel is being left at the lower wall, so that the top wall can come, and the sleeve can be accommodated. The dowel will be accommodated in the sleeve, and then we have structural grouting to make it even stronger. And then this is the precast parapet. This dowel is from the structural topping. Here you can see the structural topping of 90 mm. The precast slab is 100 mm thick, structural topping is 90 mm. So those are being left from the structural topping, so that the precast parapet would come, and then after that you can design your metal railing on top of it. So this is a typical junction for a column and beam. If you can see, there's a corbel in the column to support the beam, and then there are reinforced the dowels for the beam to be grouted along with the structural topping. Uh, and here the beam is supporting both the hollow core slab. So the shape of the beam is something different, so that the hollow core slab can be rested. And then the top of the beam is also not casted. So it's casted at one go, so the entire structure becomes one along with the structural topping. So these are some of the typical details of the expansion joint. We can see, like if your depth of landing slab is deeper, then the ledge is designed accordingly on the walls. Same case goes for hollow core slab, or on one side if you have hollow core slab, and the other side you have solid slab. These are some of the expansion joint details. One of the expansion joint detail between the structural frame column beam and the load bearing walls. And starting of the staircase is also fixed in the similar manner with the towels and structural grout. So this is one of the typical drawing where you have to mark. I'm not showing all the comprehensive drawings, but here you can see everything is marked before it goes for the production. So how it happens is we do the design, then the structural engineers, we do design as per the modules, because we know the panel size, what the battery mold can produce, what should be the height, what should be the width. We can do that. So there can be a variation of height, but the maximum height we had gone for one of the basement was 3.4 meter of the retaining walls or any of the walls in the basement. These are like total is 3.3 meters. So here we have to show all these electrical conduits, sleeves for the water supply pipes, cutout for the doors, and control switches. And bottom you can see all the corrugated sleeves which will take on the dowels from the lower floor. So these are few of the elements. You can see the column beams. These are the precast. On the right there is precast walls, and in the same picture you can see the slabs, also precast slabs. And this is the soft slab on the right bottom corner. So even the soft slab has to be designed, and with all these sleeves, exhaust, water supply, HVAC pipes, or soil or waste pipes. Everything has to be designed previously, so that the pipes can be accommodated, services can be accommodated accordingly. So this is one of the project. This is the first precast project I was handling. So this was close to 6 lakh square feet, which was completed in probably 18 to 20 months. This is another student housing, and the earlier one that could accommodate 2,500 students. This is the student housing, which you can see from SH11. It's on the west side of SH11. So this also could accommodate 1,200 students. It had 4 towers, and between second and third tower we had the common block. It had a basement, and the retaining walls were made of precast. That's it. Thank you.
Thank you so much, sir, for giving us the practical insight on precast. I think it will be very, very beneficial for the student for Design Advance 2024, because this time our theme is around housing only. So from your case studies, I think they have been able to learn a lot. So also, sir, I would like to thank you because you have showed us the construction images as well, also the drawing part and the connection details and everything. So I think the attendees have grasped uh, like wide range, right? So we have a lot of Q&A in the Q&A section. So we'd like to, if anyone has more questions regarding, please post your questions in the Q&A. So we'll be going through the Q&A right now. So for that, Chinmay sir and also Shoaib sir, I would like to invite both of you so that you can answer the questions that we have.
Yeah, hello. I think Chinmay sir, are you able to see the questions? Few of the
Let me
questions I've
just see
already answered.
Q&A. Okay, yeah.
Yeah, yeah. Few of the questions I've already answered. Some questions I think you can take. I can read out the questions if you like.
No, I'm reading it.
Acha.
So
One has asked about the sealants. Another person has asked about the costing of the precast construction.
okay. So the first one, if we go for the sealant, the only portion, if I again share the screen, can I share it again?
Yeah, sure, sure, sure,
Yeah,
sir.
yeah. So for the sealant conditions, like these walls are so good that you don't need any sealant for the walls. But for the joints, you definitely need sealants. If you can see, there are some gray lines in the joints. Uh, so these are used in the external facade along with structural grouting, so that the water doesn't go inside. So let's go to the second question. Uh, what is expert opinion regard because for single story building? Will it be cost economical?
I
So the
think he must
second
be
question by
asking.
Aditya Sharma, I couldn't understand actually.
No, I think he must be asking that cost economical if we are delivering projects by using precast technology in a smaller scale. Will it be cost effective or is it only cost effective for the larger projects? I think that is what he is trying to say.
Oh, sorry. I'm reading the third question. Okay.
Okay, so
Will it be cost equivalent as the cost in situ construction? What is cost? Okay, no. In small scale project, what will happen if there is a mass production? Then it's because in general global city they were doing the smaller duplex housing. In probably there were like tons of them, like 200 or something odd housing were coming up. So that's feasible for a large mass housing, even if it's low rise. But if you are doing it for a single house, then it might be a difficulty because there'll be cost will go up. Reason being is that the plant has to be somewhere closer by.
hmm,
Otherwise, the transportation cost would go really high.
hmm,
I think that's also is done. But per square feet area, per square meter area cost of construction, the buildings we had designed, it was close to 28,000 per square meter. So that was very economical. That's
hmm.
all centralized air condition.
Okay, okay.
Yeah.
Third question, which is by Aditya Sharma, is actually a continuation in continuation with another question. He asked about the connection details, and he continued his question in another like line. So you have already seen shown those connections, I think. That is slab to
Yes.
beam connection, beam to column connection. So you have already shown those details. You
Yeah.
asked it earlier. Now you have already shown the details. So I think this has already been answered. Another one has asked, what are the design challenges you face uh, while executing the project?
These are design challenges as such. Like I can't take my scroll. Okay, it's going very fast. Possible. I can't see the question actually. Uh,
I think
okay, let me make the screen bigger.
let us omit the answers which are already answered. It is live, only answered. This is also answered. I think, yeah, now you can see the question
Okay.
as first question. Yeah.
Yeah. What were the challenges you faced during the design stage and execution? Well, the challenges are a lot because the thing is, when we deal with precast construction, so you have to know the logic of precast construction. What are the modules, like how? Because before also designing, before designing, what we used to do is we have to see where the crane can be located and how the movement of the vehicle, the trailer can be done, and how the where the storage would be happening. That also we have to study because
Mm-hmm.
these precast elements they can't be lifted by manually. You need tower cranes and you need mobile cranes for the same. So that also has to be taken into account. And then execution actually. We used to go for site visit, but when we talk real execution at site, so there was a team from the client, Jiddal University. They used to take up the challenges, and they used to manage everything. And we had to send the design to the structural engineer. Structural engineer used to give us the structural drawings. Then when they send us panel by panel, because in any of these buildings you would have like 15,000 odd panels, which includes column, beams, walls, slabs, staircase, everything. And everything has to be marked and approved by us with the electrical, if we have any electrical points or any sleeves or anything, then we have to issue it to the back to the structural engineer, and then they have to issue it to a production to the factory, so that it can be put into production. So we always have to be like per day production for Jindal was Jindal factory was 25 number of walls, but we had to be ahead or by 100 number of walls every day, so that the factory can run, because if whatever enforcement they do, they have to do somewhere, and then they have to put it in the battery mold. uh, After that we have transportation of such heavy walls and 600 mm for tile to load bearing. Generally, conventional customer we consider them to be thinnest. Yes, those were very thin. We were like this Ecotech wall, they could start from 68 mm thick to 120 mm thick, and we are using 100 mm thick walls, and 600 wide, and the floor to ceiling height was 3 meter. Is it possible to provide simply supported precast element in seismic zone? Is there any standard? All the standard, because the Sonipat is in seismic zone 4, and all the standards have been used accordingly.
One has asked the question about the standard also, sir. So I tried to answer him. I mentioned the standard is IS 15916. So, he says, I think that question is, if you scroll down, there's follow-up question that doesn't contain any, cover related details. So, is there any other code which is used? Or maybe,
There are some structural codes, but
okay,
I'm not aware of it. The structural engineer would be aware of it, but I
correct,
can
correct,
look
correct.
it in the drawings. There
So
should
I
be some
think
codes.
they can easily find it online. So
Yeah,
that is the whole point, right? Okay.
yeah,
So there are few questions about the codes only. So I think we
yeah.
can tell them that they can find it online very easily. And as per Indian standard, one code is already established. That is IS 15916. Latest version is 2011, which I just found out. Uh, One has asked about what about the water storages? So
So this
as
building was
basically.
it. We had centralized services. So the
Mhm.
water supply tanks were in the service block, and the water supply was in hydropneumatic. So there were only fire water tanks above, and geyser above, electrical geysers for the students. No water storage tanks over there.
Okay, okay. I think most of the questions are already answered. There are so many questions coming up. Some of the answers we can maybe reply them through email, because there are hundreds of questions, and I think we cannot answer every question live. So thank you so much, sir. Uh,
Okay.
yeah, so we'll connect with you. We'll pick up the questions and also answer them via email. So I think time is already up. It is already past 11 minutes. So, Pranami, I think we can end the session. And thank you so much, Chinmay sir, for sharing with us your insight. So,
Thank you, Soif.
yeah,
Yeah.
yeah, yeah. It's nice
Yeah.
For
meeting
the
you again. It's been a
yeah.
long time. Yeah.
Sure. Sure.
Thank you so
Yeah.
much, sir.
Thank you. Thank you.
Thank you.
Okay. Okay. Bye, everyone.
Goodbye.